Just 1 second. Welcome to week 4 of our course on getting started in OpenSees with STKO. Welcome, everybody.
Morning.
Well, we do have a double video. You can, I'm gonna just turn off one while we start the sharing. Welcome back, Enrique and Larissa. Dr. Nizar, welcome everybody. Good morning, Diego. If anybody wants to take the first 2 minutes or 3 minutes to tell us how you're using STKO and OpenSees, if you want to just introduce yourself, feel free. We're gonna just wait a few minutes for everybody to get in. Diego, Enrique, did you have the chance to explore OpenSees and STKO in this week?
Well, in this week, yes. Looking at basically prior videos and repeating well the steps that you did on the first two. So yes, I had the time to get more acquainted with the software, and it's pretty impressive, to be honest with you.
Glad to know that. 1 second, I just have my Okay, we're back. Welcome, everyone. I think we can start. We're 27 people. Well, actually 26 because I'm a double agent here. So I'm going to deactivate this video and share my screen with you guys. Just tell me when you see the presentation. There should not be that problem like last week of overlapping things, but if you have anything to suggest me, like that you don't see something or you don't hear very well, please just interrupt with the microphone.
No, it's perfect. Thank you.
Thank you. Thank you, Larissa. So welcome back, everybody. Today I'm gonna be a bit like longer than usual, not 30 minutes, maybe 40. I'm not sure because I have a lot of stuff to say, but we'll see. So for whomever is new to this course, we're doing a series on Get Started in OpenSees with STKO. Every class is like a 30, 40 minutes with a question time at the end. We usually have an assignment, but for today we don't have because it's purely theoretical. And we have a forum that you guys can go to. I'm not gonna click on this now, but you will plenty of time to see that later. And you can just post questions there for us if you need to help with anything that you're modeling. So we're getting now to the core part of our course. Today we're going to talk about geometry, interactions, selection sets, and local axes. And the next webinar or next week will be on physical properties, so don't miss that. Just write it on your calendar. Just for your information, in June and October, between June and October, we're going to do one every week, apart from August. So I will be here every Wednesday at 6, waiting for you to join me. So today, as I said, we have, let's say, our class divided in 4 sections: geometry, interactions, selection set, and local axis. Let's just get right into it. For geometry, we're going to just talk about how is geometry built in OpenSees, how it is that it's built and set in STKO, which are the CAD commands that we have in STKO, how is geometry related to mesh, and the query command that you can use during your modeling. So first thing that you guys maybe already know, if you ever done one of your TICL scripts and run a model in OpenSees, is that when you build a geometry in OpenSees, you have to define the locations of the nodes. So let's say this is the main first step that you do in the model builder that will actually create the nodes in your model and position them in the locations that you define. The same thing is done in STKO, but it's done graphically through our interface. We have embedded a lot of CAD tools so that we can create this. This is exactly the same geometry. So here is your script, and here is your model in STKO. They represent exactly the same structure. But of course, in OpenSees, you have to write node by node, just writing your TCO script. Instead, in STKO, you can draw as if you drew in any CAD modeler, and you will have a work tree navigation panel that you can go through and see the geometries that you've drawn. We have like support files that show you these two models, but I'm not going to go through them because it's really, really basic for now. The only thing that you really need to take care about in the beginning of your approach to STKO is that we are using a boundary representation approach to geometry and not an orphan mesh approach. What's the difference between these two approaches? So in orphan mesh, which is used by other FEM softwares, in orphan mesh, the finite element mesh exists without any associated geometry. This means that you can move a node, for example, of a mesh, and the rest of the mesh will, let's say, adjust to the movement. The mesh information is orphaned from its parent geometry. So there's something that's separated one from the other. Instead, in boundary representation, geometries are defined by their boundaries. So for example, the model is constituted by topological components, faces, edges, and vertices, and the connection between them. This is something that is really clear when you, let's say, browse to the work tree in STKO, but it's something really hard if you're coming from another software to just like get acquainted with at the beginning. For example, in some software, you will just like draw one node, another node, and then the line that connects them. And this will just be your structure already, let's say, completed. Instead, in STKO, if you draw a node, another node, and then a line, you will have 4 vertices, the two one that you created at the beginning and the edge, because the edge is actually a boundary representation, and it needs 2 vertices to be represented in the software. So for example, a face is bounded by is a bounded portion of a surface, an edge is a bounded piece of a curve, and a vertex lies at a point. So just remember these, let's say, as a concept when you start your modeling in STKO. There's a lot of CAD commands that we have introduced in STKO. You can use any of them. There's some that are like overlapping, let's say that they do the kind of the same thing. I will just not go through their definitions because I think they're very straightforward. This is here for you to go through if you need to kind of, let's say, study a bit by your own. But what is it important is to understand the differences between some of them. For example, there's some Boolean operations command like merge and union, and there's a different command called make compound. It's important to understand the difference between these commands because, as I said before, geometries in STKO are boundary represented. So you need to, let's say, if you want to join 2 geometries, because your structure needs to be contiguous in order to not be singular and for you to run your model, you have different options. First, you can use the merge commands. The merge commands will actually merge the geometries. So for example, these are 2 solids that were adjacent to each other. When merged, the face in between them will just be 1, because of course, the merging operation will merge the face that's, let's say, adjacent with the next one. Instead, the union command will try to unite the solids together. So the face in between will disappear. And at the end, the make command compound instead is actually, has the definition before that I didn't read to you, is a composite geometry that preserves the geometrical features of any geometry that you're trying to compound. So in this point, if you click in your model, you will see that there's 2 faces. This is like the way that you will visualize the options to select different items if they are overlapping in STKO. So whenever is it that you make a compound, just remember that there's gonna be 2 faces overlapping in this place. And the same goes for faces. If you are joining 2 faces with a make compound, there will be 2 edges in between. If you're sewing faces or merging faces instead, you're doing the same operation. There's gonna be 7 edges, so the 6 on the line on the sides and the one in between, 6 vertices and 2 faces. just a quick tip that you guys can use when you work in STKO. I'm just gonna show you very quick. So for example, if I am drawing my face here, and then I'm copying the same face beside it, and then I rename the second face, call it Francesca, for example. If I do the make compound command between these two faces, and then I go for the selection of just edges here in the selection in the quick toolbar, and I click here, you will see that I will be able to just select one of the two edges, and they will be inside of my geometry. This thing about the renaming is not showing here with the compound, but it's showing here. For example, if I have the two geometries instead already still disjointed, I can see which one I'm selecting between the two. Instead, if I was, let's say before, with the two automatic naming options, it would have been difficult for me to identify which one is which, if the one on the left or the one on the right. This is just a quick tip that you can use when you're modeling. So going back to our presentation, the same goes for polylines. There's different options to join polylines. There's the make wire command, which is the one that in frame structure we use all the time. You cannot use the make wire command if your polylines are not contiguous. So if there's not a vertex in between two edges that you want to be joined. If I try to do make wire on something like this, two polylines, they're just intersecated but don't have a joint element, a joint node, then it will not work. What I need is like two lines that are contiguous one after the other. Instead, if I do the merge command, I will have the point here in between. It will be created by STKO automatically. Instead, if I do the make compound again, the two geometries will be just kept separated inside of the compound. This is really useful tip. Whenever you're drawing something in STKO, if you haven't done that before in your CAD, normal CAD environment, or in Rhino, or in another software that you're importing your geometries from, this is really useful if you're, for example, drawing a section and you need, because in STKO there's not many snaps. For example, there's no perpendiculars, there's just the node and the midpoint. So this will help you if you draw two perpendicular lines, you can get the node by merging the two lines. So it's really important that you understand how to join your geometries, because the mesh will reflect the geometry that you built. So disjointed geometry will create a disjointed mesh. This is an example that Massimo used in a previous webinar. You can just click on this link to watch it. It's a really useful one because it's on all common errors that people do in STKO during their modeling procedure. The three examples are from the same, let's say, two beams that in the first case are not connected at all. So it's two separate faces. And as you can see, when you run the model, the two faces are disconnected. The second example has been run after the creation of an equal DOF constraints in this node. And therefore, the two geometries will be connected. And the third example is the two beams have been connected by using the merge command. And so you have a single beam without even the, let's say, the representation of the line in between. Because of course, it will be considered by your mesh, but you will not see it as a relevant line in your result. So there's difference between joint geometries and disjoint geometries in your models. This, of course, had worked in the example because both of the beams at each side were fixed. But for example, if you have an element that's disjointed from the rest of your model and you try to run it and you haven't fixed that in the space, that will not work. So just so you know, you can build numerous models in the same environment in the render view, so in the same CAD document in STKO, but you need to fix everything to be able to run your model. And this you can actually check by using this very useful tool, which is the query tool. You can access it in STKO by going in query geometry here in the geometry tab. And for example, right now, my faces are not connected. If I select the free edges, you will see that it will select all the edges of both of the faces, even the one in between. But if I merge my two faces and I do the same operation again, It will not select the edge in between because it's not free anymore. This is a joint geometry. I'm sorry if this is kind of boring at the beginning, but it's really important to avoid making mistakes. In the query geometry tool, you have a lot of other functions. They're really useful if you have large models. The most used one by everybody is the query length. Just remember that if you click ask to unselect your geometries, you will just exit also the tool. So we provided you with this little unselect all button to just reselect what you want. You will be able to use the quick toolbars here. And for example, if I go on edges and I query the length of my edge, it will be printed in my terminal. So going back again to my presentation, as I showed you the query length and the other tools, there's also a last tab that will give me the mesh information. Normally, this is printed in the terminal when you run your model in other softwares. Here, you don't need to run your model to know that. You can just see that on the side. So we're done with geometries. I'm just gonna provide you with this little utility that you can try to modify and adjust to your needs. There's another way that you can build geometries in OpenSees and STKO. So we said we have the STKO file, we have the CAD document that you can build by drawing directly in the render view. And also you can use the Python API by using the PyMPC exported functions and methods that are specifically used in STKO. If you want to, let's say, read more about this example, I'm not going to go through it like piece by piece, but if you go here, we have our documentation, and this is one of the examples that we documented really in detail. So I'm just going to show you what happens if you, let's say, open a new model and open your script editor and just load your utils3 file, which is this one that I'm talking to you about. This file is actually defining a function to add a geometry and manually drawing every vertex with their coordinates, the edge in between the vertex, making a wire in between the edges, making a face with that wire, and then at the end, building an actual solid. So if you just click run, you will get your cube, as I defined at the beginning, like positions at 0, 0, 0, as you see here, with the dimensions that I assigned to it. Of course, this is a really basic example, but just you can see the possibility and the potential for you to build like routines to create large geometries in seconds, really already inside, and visualize it right away, which is not possible in, of course, if you just are programming your STKO scripts. Because of course, all the programming capabilities are already inside OpenSees, but with the Python API, you can also see them right away in our preprocessor. So going back to our presentation, we pass now talking about interactions. So interaction is a concept that does not exist in OpenSees as it is. They are a concept that we introduced in STKO because we needed to find a way to connect geometries and elements that cannot be drawn. For example, zero-length elements are collapsed geometries that you cannot really draw with our CAD interface. Like you can't, if you go here and you try to draw a line by clicking in the same spot, it will not do anything because of course, it's not possible to draw collapsed geometries in STKO. So what we try to do what we did was insert this concept of interactions. Interaction can be used in two ways: to assign kinematic constraints and assign elements. In all interactions have two types of nodes. We can call them primary nodes and secondary nodes. The primary ones are the one that you define first, and the secondary one, the one that you define afterwards. In the kinematic constraints, the primary nodes are the retained nodes, the ones that are going to be kept in the equations during the run of the model. And instead, the secondary one are the constrained one, so the ones that will move exactly equally to the retained nodes. There's still the old notations in our software, unfortunately. We still have the terminal telling you about master and slaves, where we're trying to change the way we call these nodes. Instead, when we are doing element assignment, for example, for zero length is an element in OpenSees that we assign to interactions. The primary nodes are define the beginning of the elements, and the secondary nodes define the end of the element, giving you the orientation of it. There's different kinds of interactions. The ones that you will always use for sure is node-to-node links. There's very few occasions that you will use node-to-element links. There's different types, of course. At times, the way you define the primary and secondary nodes, so which one goes first, is really important. For example, in rigid diaphragms, kinematic constraints, it has a physical meaning. What is it that you define as constrained, and what is it that you define as retained? The constraint node is the one you define at first, and the retain will move exactly as the constrained one by multiplying the distance for the rotation of the constrained one, of the retained one. So just be careful that you define them in the right order, because in certain cases they have an actual physical meaning. For the equal DOF, for example, is a bit the same, because the equal DOF is just telling you the displacement of this node is the same of these other nodes. So that's not really important. And there's also a lot of types of element assignments: zero length, true node links, all the contact elements that you can think about. Of course, the way that you define an interaction, I don't know if I already showed this last time, but I can show this now. For example, if I open the file from last week, I had rigid diaphragms positioned in my structure. In this case, it was really useful for me to define some selection set for the interaction definition. If I go here and remove the interaction and create it again, I'm going like renaming the interaction, define the type, going okay, then selecting my master geometries, my retained geometries. And I already have this selection set that I can use for this selection. I click enter or on my keyboard, or press the right click on my mouse, and then it will ask me to select the secondary nodes. So to do that, for example, in this case, I can go in a flat view, or let's say maybe a plan that it's easier. And then I would select all the nodes in my border. Yeah, I did a mistake. I'm going to start again. So I have a rigid diaphragm. I go here. I select my master nodes like this. And then you have to remember that you have to use these tools to be able to select only what you want. In this case, I only want the nodes. So I go around like here and here, all around my building. I select the nodes. Then I go in the front view. I don't want the one at the bottom. So I click Control and I deselect the one at the bottom. And of course, I don't want the one in the staircases, because of course they're not part of my rigid diaphragm. And now I have all the nodes that I want. I click enter or right click on my mouse, and here I have my interaction. Once I define the interaction, there's two things I can do with it. So in this case, it is a kinematic constraint. So I go in my condition, I open up and I define my multi-point constraint, the rigid diaphragm. And of course, as for all condition, I have to click before I click OK on the assignment that I want to do. It's not like physical and element properties that I have to drag and drop it, and I click OK. If this was an interaction defined by an element, I would just have dragged and dropped the element on it. And of course, just remember, there's also the last button on the quick toolbar is select interaction. So if you unclick this, you will not be able to select your interaction. Again, going back to our presentation, just the type of interaction that you define will also be relevant when you are going to choose in the analysis command the constraint handler that you want to use in your analysis. This is something that we're going to speak a lot about in our analysis command classes, so just don't miss those because they're very important. And going forward, we're going to talk about selection set. This is a very useful tool that we have in STKO. It's a multi-purpose tool. Sometimes it's necessary to use one. For example, if you want to set up a monitor, I will show you always in the model of last week. In the monitor, or well, in the second one, not in this one. Turn your mic off. I'm gonna find who it is. Christian. Oh, I don't know how to do that, but they stopped talking. Good. So in the model from iClose STKO, I got distracted. Sorry, guys. I wanted to show you how with the monitor you could use selection set. Let's just wait for it to reopen. Anyway, sometimes selection sets are required in STKO because you need to select them from a drop-down menu in order to use them for your purpose. If you want to monitor a specific result, you have to define the element or the node in which that result has to be extracted from. If you want to use a region command, which means you're analyzing your model just recording a part of the model, so you need to select which part, and you need to put it in a selection set before you do it. And if you want to operate an analysis in displacement control, for example, controlling the movement of a specific node, you need to select that node. Otherwise, you will not be able to do your displacement control. So here I'm going back in my STKO. I open the file from last week. As I said, in a monitor, you need to create a selection set. Here will be required for you to do that. But there's so many other ways that you can use selection set. This is actually a question that you guys posed for me last week because you already asked it. I think Larissa was it. So you can use it, let's say, as a container of the things that you want to define beforehand. For example, the interactions I created before would have been much faster if I had created the selection set with all the sides nodes of my structure, the one on the borders. I would have just done as I did for the master node, selecting them right away without having to click or re-click. I strongly suggest that you create selection sets right at the beginning of your model, because even if they change, you will use them and you can update them during the time. So for example, to update a selection set, if I go here in beams, and I don't know, for example, this beam was not in it, I could just like select only edges, go here and add it to my selection set or remove it. Okay, so this is how you update selection sets that are already existing. Going forward at our last steps of our presentation, we have local access. So here it's getting a bit more complicated. We have to go to one of the concepts that is inside OpenSees that at the beginning it's a bit difficult to understand. So what is it that it's a geometric transformation? You will see that for example, if I go to the first example that I provided you guys in week 1, so I think example 2. Yeah, okay. So here I had to define, this was our 2D frame structure that we did in the first week. Whenever I had to define an element, I have to assign a transformation tag. The transformation tag was defined initially here. So here was a very simple case because it was a 2D case. But when we are in 3D, the things get a bit more complicated. Why do we need this? So taking it a step back, whenever you draw a geometry in OpenSees, like now we're just talking about OpenSees, I have STKO images down here just to help me explain the concept, but let's imagine that you're just doing your TICO script. So I'm building for example, my beam here. I build it in the space. I have 2 nodes. Here, naturally, there's a mistake. The nodes have to have different indexes, otherwise it wouldn't work. So I'm building my 2 nodes. I'm giving them the coordinates. So tag X, Y, Z in reference to my global system of coordinates. I want to tell OpenSees how it is that I will have to position this section based on the local axis of this element. But to define the local axis of this element, I can't really it will not be done automatically. I have to define it myself. So what is it that the geometric transformation command does is giving a temporary vector that will be placed on the x zeta plane that the user defines. So the geometric transformation command I will show you here, it will ask you the 3 coordinate of this vector that is positioned on the x zeta plane. It's important, it doesn't matter that it's actually on the local zeta axis. It just has to be on the plane, and it has to be not aligned with the x local axis. And with that, I can find my y local axis, because I can just do the cross vector between the cross product between the x axis and this vector, and then renormalize again and find my actual zeta axis by doing the cross product between the x local axis and the y local axis found just before. So this is just a whole system that it's in, let's say, embedded in OpenSees. So not embedded, maybe is not the right way, but anyway, it's structured in OpenSees for you to define the local axis of each of your elements. This is because a beam is not, it's a collapsed geometries inside. So whenever is it that you're drawing a solid or constructing a solid in OpenSees, you already have, it's really easy to define the local axis because you have all the faces oriented one in comparison with the other. Instead, with the beam, you don't have that. You have to define how is it that your section will be drawn around your characteristic axis, which is the one that goes along the edge that you're defining. So this is just to explain this complex concept of geometric transformation. I hope it's clear. If it's not, please do ask questions, because also there's Massimo coming here today. I can turn on the video so you guys can see him too. Yeah. And to explain this concept of geometric transformation, that it's really important if you want to make your own TCO files and if you want to understand how it works inside OpenSees. In STKO, of course, there's an automatism that does that for you. So the only thing that you have to understand about the geometric transformation is that for beams, for example, is the only way that you can assign geometrical nonlinearities. This is the way that you define if we are considering geometrical nonlinear effect in our elements by assigning not a linear transformation, but a p delta or a coordinational one. But you will not have to input the coordinates of this x zeta vector, because this is something that in OpenSees is done automatically. How is that done? We have a default way that we assign local axis to elements. So for beams, whenever you draw, you start drawing from a point to another point, the characteristic axis will be just lying on that direction that you defined as you drew your vertices. And the same if you do it on the other side. Instead, for faces, it will go, let's say, around the, it will depend on the direction with which you define the corners of your face. So if you go in a clockwise direction, it will go down. If you go in a counterclockwise direction, it will go up. So just to complete the geometric transformation concept, this is the command that you use in an TCO script to build one. So as I said before, you give it a tag, linear, p delta, or connotational. Sorry, you define one, then you give it a tag. Tag is very useful if you have different elements, for example, columns and beams, and you have to define different transformations for each of them. Because of course, vertical elements and horizontal elements will have local axes in different directions. And then there's also the offset that actually not many people use, but just for you to understand, the offset will allow you to apply an end offset or a section offset to your beam. So if you want to build your model in a TCO file and just use our STKO conventions, you can just assign for beams this actually x zeta vector, and this one for your columns, because this is our, let's say, default way that we do this. If, for example, you have drawn your geometry, but the local axes are not coherent inside your model and you want to change it, you can use the reverse command. So for example, if I want to make this beam coherent with this one, I will just reverse its direction and it will become the same. If I want to make this face coherent with this one, I can do the same, but I can also use the Make Coherent option by defining just the direction of the characteristic axis. So for a beam, it's the x-axis. For a face, it's the z-axis, the one that's normal to the surface. And in this case, I want my z-axis to go upwards in the same direction of the global z-axis. Just remember that if you move or explode your geometry during your modeling operations, if you had modified the local axis assigned by default in STKO, they will be lost. So this is something that we're trying to fix. We're going to do it soon. But for now, just remember this. And I know this sounds super boring, but it's important if you want to read your result in a coherent way, that all your model is drawn in a coherent way in terms of local access. Something useful that you can use. This is another utility that you can use in the Python API. It's actually, it's a script that you can use to select all of the columns in your model that are not pointing upwards. Let's say, assuming that our default is that the columns will point upwards in their local axis orientation. I will just show you how it works. For example, this is my model from last week. Let's just put our thing like this. I am going to show you the local axis. They're all coherent right now. But if I select, for example, all of these edges and point them downwards, reversing them, you will see I changed the direction of the local axis here. Maybe this had happened when I was drawing them. Maybe I extruded all the points for the base columns, and then this one was missing, and I drew it like from here to here, and it just got oriented wrongly, or let's say differently. So if I open my script and I go in this utility that I showed you, what it is actually doing in a first loop, it will identify all of these geometries and put them in a map, in a dictionary. Then it will just include them all in a selection set created just for this reason, for this purpose, and use the select command to select the selection set. Select set selection. No, sorry. Yeah, selection set select, exactly. And then it will erase the selection set because we don't really need it. We just need the selection to be highlighted so that we can use the reverse command again. Now, I know I did it on purpose, but if you had done it like just yourself by accident, so if I run this script, it will select all of my columns that are not pointing in the right direction, and I can use the command reverse to do this. This is very useful if you have a large model and you don't have to go and look through each and every little piece. So it's all for today, I think. Yes. Yeah, this is just to remind you, it's been 4 days that I don't make any units mistakes. Please don't do any yourself and use our consistent unit table for reference. Thank you for your attention. And if you have any questions, we have Massimo here to help us answer if there's something complex. I know today was very basic, so you can come in the video.
Everyone.
Hello.
Ciao, Larissa.
Ciao. I have a question. Because I had the problem when I was so I had this module that I merged, and then I copy the module, and it like start copying and copying inside. Every time I was trying to copy, like if I selected this complete module with different faces, it appeared this box saying like copy 1, copy 2, copy 3. So every time that I was trying to copy, I copy like a lot of copies.
Yeah, so did you remember what I showed you before? Like, so if you have overlapping geometries,
yeah, but
what happens is that you will see, like, for example, if you draw elements overlapping with each other, whenever you see when you select that they are overlapping, you get a little list of them. So you
yes, but the thing is, I just wanted one of those. If what I don't understand is why every time I was copying, it's like I was dragging a copy, and so I copy once, then I copy on top. So I copy that one. There was one copy, but on the bottom I have like 2 copies.
So when you copy, like the copy operation does not work as in AutoCAD. You cannot just take one and copy an infinite number of times.
Okay.
Yes, but you cannot do it with a certain distance. Like, for example, if I have 2 elements, let's say I have these 2 lines, I move it from here to here. If I want to copy these at a certain distance from here, it will not create a snap in the So this is something that I normally make mistake with a lot of times, because I think this will happen, but it does not happen. I mean, in this case, it does because it's a snap from the grid.
Yeah, because actually the geometry is not.
Yeah, exactly. The geometry does not exist yet. So it will not create a snap until you just click enter and exit from it. But I don't know why it's happening that you are copying a lot of things that you don't want. Just remember that when you have an overlapping thing and you want to copy it, you have to select it from the list first. So like this, you will just copy one. But if you select, for example, with this kind of selection, you will have both. So if I move this element here, I have moved both of my lines. So whenever you want to select overlapped geometries, you just use the click on and not the rubber band.
Okay, but so in the case that this happens, so suddenly I have these two. If I remove one, like I select it and I delete it.
Yeah, like
And
this.
then I merge everything because I was trying to, I had a pattern, so I create the pattern, so and then I duplicate the pattern. So the thing is, if let's say that I create two copies, so I remove one and then I merge everything, would I have any problem, or it would be fine?
You will still have overlapping geometries.
Yeah, actually, when you have perfectly overlapping geometries, you can try to use the merge command, and if they are exactly overlapping, you will end up having only one of them. So you will actually remove the overlapping geometries. But keep in mind that if you have a lot of them, it will result in a complex Boolean operation. So I do not recommend to do very complex Boolean operations, because if you do them repeatedly, it will mess up your model.
Yeah, because the problem I had is like I realized it because when I went to I didn't realize I was copying a lot of time the same thing. So the thing is, when I went to the properties, some of the faces were like in a darker color than the other ones.
Well, the darker color actually is
Okay.
not due to overlapping. The darker color
is the local axis.
is well, actually, it is a facility that we use to understand what is the direction of the normal of a surface. Because a surface does not have a real thickness. So we need a way to understand what is the front of the surface and what is the back of the surface. That's why we use the same. For example, if you are looking the surface from the normal vector pointing towards you, you will see the light color. If you look at the surface from the opposite direction, then you will see a darker color. It is just a utility that we use to easily visualize.
Yeah, but
that does not mean there's any under it.
No, this I realized, but this happened when I was doing the geometry. So I realized this, when I do one on the other side, it changed. One was dark and one was light. But the thing is, when I went to the property assignment, well, after I assigned the properties, I realized that some of the faces were darker, and then I realized that they were like two one on top of the other. I don't know if this was just a coincidence or and this is why I realized I had copied a lot of times the same thing. And this is why I deleted and I merged it and it disappeared, the colors.
Yeah, actually you have to understand why you had all those copies overlapping. Probably you clicked on the copy command and then you started clicking on the same point over and over again. Or sometimes it happens because people want to perform a parametric copy. So you can move your object and start typing the distance, okay? But every time you type the distance, you have to type an increment. Otherwise, you will copy many times on the same location. So actually, it's just a mistake you did when you try to copy, okay?
Okay.
Just to as a general rule, for example, here, what if I wanted to make this frame and I copied the same square over and over again?
Yeah, I just overlapping there.
Yeah, no, so here in between I have edges overlapping. If I go just with the edge selection and I go here, I have two edges. Now, maybe here it's very easy. And if I do the merge command, I will not have overlapping edges anymore. Let's see. I have to.
Probably you can also switch on the labels.
Yeah. too many labels. Yeah, for example, here I don't have, but what happens to me creating, let's say, structures like this one, if you create a floor and then copy it up and up and up again, when you merge all together and you have a lot of overlapping things, not all the time they will be merged. So as Massimo said, just try to create your geometries singularly and then copy them singularly if you can.
This is true for any kind of CAD software. You have to limit the number of times you use Boolean operations because they are very complex. And so the underlying geometry can become something like imperfect. Okay, so if you try to minimize the Boolean operation, it's the best thing to do.
Okay, thank you.
I think we have a first question there.
Yeah. Could you give us one practical example how we can apply make compound commands in our model? Why would we want to use it?
Okay, so actually the compound itself is not a real Boolean operation. I don't know if you already mentioned it.
No, I didn't say that it's not a Boolean operation, I just said it's different.
Yeah, a compound is just like, I don't know if you have practiced with AutoCAD, but it's just like creating a block or a group. Okay, so you take two geometries and you put them together into a group, but without making any Boolean operation. So, for example, if you have two faces and you group them with a compound, the only advantage is that you have only one item, okay, but the geometry underlying these two items is not changed. So if they were two separate faces, they are still separated because it is not a Boolean operation. Practical uses is, for example, when you have very complex models with a lot of disjoint geometries, your worktree will be very, full of items under the geometry there. So sometimes I keep those objects and I put them together in a compound. For example, I do it for the master nodes of the rigid diagram. If I have a lot of floors, you will see, for example, if you have 10 floors and you draw 10 master nodes to the rigid diagram, in your worktree, you will see 10 geometries, one for each master node.
We have it.
I think we take all of them and I put them into a compound. So I'm not changing the geometry. I'm not trying to do any Boolean operation. I'm just grouping them into a common group. Okay. So that is the only way, the only reason why
I didn't do it in my model, so
yes, for example,
you guys can do it. So you select all your master nodes.
Geometries. One can be called, for example, structure, and the other master floor nodes. It's just a way to keep your model more organized.
Nobody geometries. Make a compound, select your master nodes. Maybe they're not showing.
No, you're not. When you select them,
Let's go back.
in selection set, you're selecting the sub-geometries. You can select them from the geometry.
Okay.
For example, there, you select all the geometries there. Select, and so on, select. All of them, make compound.
There it is.
Okay, so you can rename it, for example, master nodes. So it's just a way to keep your document.
Your work tree clean.
Yeah.
Yeah.
But it is not actually changing anything. So if you want to attach two faces that have a coinciding edge, you either need to use the two faces or the merge command. Okay.
Like here. So we had another question. Could dissipation devices like tuned liquid dampers be modeled in STKO? Now we're going like all the way.
Yeah, actually.
You're welcome.
Yeah, this question is not actually related to STKO, but actually to OpenSees, because it really depends on how you want to model them. I assume you don't want to do a micromechanical model, okay, a 3D model which tries to model the dampers by defining the full geometry. I imagine you want to model some kind of spring with an equivalent nonlinear model, but this is a topic related to OpenSees, so you have to find a way, you have to find out if OpenSees has some uniaxial model that can represent this kind of dampers. Actually, I'm not familiar with them, so if you have some references, probably we can see if they are in OpenSees or not. Is it clear?
Hello, Massimo. Can I ask one question? Can I ask a question?
Of course, go for it.
Okay. First of all, do we have to set grid line before starting? I mean, is it necessary to set the grid lines distance between two, or we can start without setting? Because in one of your seminar, you set the grid lines like 100 mm between the two lines, or we can.
Actually, it is not necessary. It is just a support. For example, we have a grid snap. Okay, so it allows you to, when you draw your line, your points will automatically snap to the grid spacing. Okay, so sometimes it is useful. For example, if you know that all the geometries that you are going to draw are actually spaced by a precise amount. For example, the distance will always be a multiple of 1 meter. You can set the grid line distance to 1 in such a way that you do not make mistake, okay? But it is not mandatory. It's not like the grid, for example, that you see in SAP that you use for building your model. It's just a support. It's like in AutoCAD, okay? So whenever you want to draw something, you can either draw it by typing the coordinates, or if you want to make sure that you draw an exact quantity, you can snap to grid lines. And in that case, you can put the grid size to a multiple of your typical unit, okay?
Okay, thank you. Another question is regarding the Make compound command. For example, if I want to draw the zero length element, do I need to first make to use the Make compound and then assign the zero length element properties to that particular node? Is it the right way to?
Actually, well, let's say assigning an element property always should be done after you draw the geometry. So this is clear. Now, regarding the zero length, it is a different topic. The zero length element does not have, or typically does not have a finite distance. They have a zero distance. And that's the reason why we introduced the concept of interactions. Because, for example, in any CAD, you cannot draw a line that has a zero length, okay? So the reason for that is that we introduced the interaction. So whenever you want to model, for example, springs or kinematic constraints that cannot be represented by a real physical geometry, you can use an interaction that connects them, okay? Like in this case, Francesca is doing an example, but you're not sharing your screen.
Oops.
Yeah.
Yeah.
So typically for a zero length, what I do, okay, so you can delete it and show it again. So imagine now that line, yeah, okay, perfect. So imagine that the first line and the second line are actually sharing the same position, okay? And you want to connect them with a spring, so with a zero length, for example. You have to use an interaction because there is no finite distance. Now in this example, there is a finite distance, but you select the primary nodes, then the secondary nodes, right click, and then you have an interaction. And then you assign both the physical property and the element property to the interaction. Okay? This is the typical way you can create zero length elements.
This, for example, we do, and then we move back the line in position.
Exactly.
So you're able to visualize the interaction that you created and then collapse it in the point that you wanted to stay.
Okay. Thank you so much.
Okay. So actually, yes, the Make compound has actually nothing to do with zero lengths themselves. As I said, the Make compound is a general command. It's just used to group a number of geometries.
Then we have another question, how we can consider adjacent building or structure in our models.
Well, it really depends on how you want to consider them. For example, if you want to consider adjacent buildings to see if they touch each other during an earthquake, you cannot just simply put them one next to the other because they are two separate geometries, so OpenSees will not perform any kind of contact detection. So if your aim is to make sure that to model the contact between them, you have to use some zero-length contact element. Is this what you want to model when you talk about adjacent buildings?
It was Christian's question. I don't know if you have a mic. You can also
Yeah, if you have your mic, you can.
just pose the question live.
Oh, we missed a question from.
Yeah, we will go back. Actually, we did answer. Maybe there's another one. No.
No, we answered to the
We answered the
distribution
question. Now
devices.
we go back.
Yeah, as I said,
Distribution.
regarding the distribution devices, you need to find the corresponding uniaxial law in OpenSees, and then you draw a zero-length element, and you assign that uniaxial model to the zero-length element. So once again, regarding
Our adjacent building question.
Yeah.
Christian, do you want to specify what is it that you want to model
yeah,
about?
when you talk about adjacent buildings, what you want to model, for example, if they interact with each other, if there is contact between them.
Okay.
Yes. Okay. So if you want to see if there is contact, actually you have two options. You can keep your model separated. You do an analysis of the first one, then of the second one, and then you measure the relative distance. If it becomes zero negative, then you have contact. You would have had contact, so you need to adjust your analysis. If instead you want to model contact during the analysis, you need to put both buildings in the same model. But this is not sufficient. You need to create some sort of interaction, which is a contact element, if you want normal and frictional contact. Or if you want a simplified contact, you can create a zero-length element with a uniaxial material called ENT, which is the elastic no tension, which is basically a bilinear material, which is very rigid in compression or completely with a zero stiffness in tension. In this way, when the two buildings separate, they will have no resisting force, but when they touch each other, they will have a very high force that will prevent penetration.
Where is the EMP?
Uniaxial materials.
Uniaxial material.
Then it should be under other, and then there is something called ENT somewhere. Elastic no tension should be somewhere. Or some standard, go to some standard probably. ENT. This is the elastic no tension. If you put your model like I said, put 1000 for example, and do a cyclic, not symmetric, but yeah, like this, for example. Try to do an analysis, you will see that in compression you have the stiffness, in tension you don't have anything, and this is useful to simulate in a simple way unilateral contact, but without friction, because this is a simple spring, so it will just prevent normal compenetration on those. If you want a more sophisticated approach to contact, you have zero-length contact elements that they actually have a coupling between normal contact and frictional contact, but they are typically used in detailed contact modeling. So in your case, I think it is sufficient to put some zero length between the joints, the beam column joints of the different buildings with an elastic no tension material. That should be sufficient. Okay, go back to the chat so we see.
Thank you for your question, Christian. I'm gonna stop the sharing. Is there anybody with some more questions? We still have a few minutes. If anybody has some doubts about their models, doesn't have to be about what we talked about today.
If you have some doubts, some questions.
Okay, I think everything is clear. I hope I gave enough time for people to, because last time I did not. Let's just wait another second.
Yeah, just a couple of minutes.
Dinner?
Dinner.
Yeah, almost time. I mean, not Italian dinner time, but still. Okay, guys, so I'm gonna upload the files as always on the website. You will find them by tomorrow, and I'll see you all next week on Wednesday at 6 p.m. We'll talk about physical properties and also something about sign conventions we have to prepare. And yeah, so please join me again, and thank you all for participating and for posing your questions. I'll see you all next week.
Thank you, everyone.
Thank you.
Thank you, everyone. Bye.
Thank you.